So in summary, a data model is basically an abstraction to represent and understand the nature of data flow in an information system, such as a machine learning system. It is basically a visual, for example, a chart or a graph, something like that, or it can be a mathematical representation, for example, an equation of either a whole information system or a part of it. Well, the goal of creating a data model is to illustrate the type of data that are being used and stored within the information system or the machine learning system, and the relationships among different attributes present in the data. Now, when it comes to machine learning, there are many different types of model possible, and they can be classified based on different categories. So the first type of classification is a probabilistic versus non-probabilistic model. A probabilistic model is a model which provide a probability distribution over n classes. For example, let's say you have, after executing the learning algorithm over the training dataset, you got two different classes, let's say C1 and C2. And then you have a new data point, let's say X new. Whenever you will pass this data through this model, these new data points or this new input variable through the model, what you will get as output is what is the probability of this X new to be in class C1. Let's say this is 0.01. And also, what is the probability of X new to be in the class C2? That will be 0.99, something like this. So basically it is outputting some probability term like 0.01 or 0.99, which gives the chance of that data point to be in that corresponding class. An example of this type of data model is logistic regression. You will learn more about the logistic regression when we will discuss about the specific model in future lecture. Now, non-probabilistic model, or sometimes we call it a deterministic model, are usually those which output only the most likely class that the input data instance belong to. So for example, let's say in this same example, if it is a probabilistic model, you got the probability, like there is 0.01 probability to be in C1 and 0.99 probability to be in C2. But whenever it is a non-probabilistic model, it will only say that the data belong to C2 over here. And so it can give the output like, well, X new belong to C2. And that's it. It will do not give any probability of C1. What is the probability of X new to be in C1? It will just say that X new belongs to C2. That's the deterministic or non-probabilistic model. The other way to classify different type of data models are parametric versus non-parametric model. In parametric model, no matter how much data you throw at the model during the training process, the model will do not change its structure. Or in the other way, the parameter which are responsible for the structure of the model will not change at all, even if new data is inserted in the training data set. For example, a neural network. Once again, you will learn much better about all these things when we will go for the specific model, but just to give you an idea, in neural network, many different neurons are stored in different layers. So let's say there are 2 different layers and there are 3 different neurons, and that's the model. So and every neuron of each layer is connected to all the other neurons of the other layer, something like this. So this is basically an all-to-all connection, let's say. Now let's say you define this model on a training data set D1, where there are, let's say, m number of data points, m number of records are there. Now let's say you have added several more, another 10 or 1000 or 1 million, 1 million data point are added to this data set once again. And so this addition of more data points is not going to change the structure of the neural network. It will remain same as it was before. So once again, even if you throw more data in the training data set, in case of parametric model, the parameters which defines the structure of the model will never change. Whereas in non-parametric model, do not make any strong assumptions about the form of the mapping function. So it can take the form like a straight line, or it can take the form just like a oval or ellipse, or it can take any type of other forms like this. And this shape totally depends on the data set. Like if you throw 1 million more data points in the data set, the shape of the curve will change. So let's say for the first m data points, you got a curve like a straight line. Now whenever another extra 1 million data point you have added, the parameters of the model have been changed, and now the structure of the model have been changed totally, and now it is behaving just like an ellipse. Let's say you have added another 1 million data points in the data set, and at that time the parameters have been changed in such a way so that the structure of the model will be something like this. So that's about different types of model, and I'm pretty sure you will get much better idea of what is probabilistic, non-probabilistic, and what is parametric or non-parametric when we will learn the corresponding models.